Alright, so we're going to look at solving quadratic equations, but we're going to do it by completing the square. So first thing we always do is, it is quadratic, so let's set it equal to 0. So 9 squared minus 18, n squared minus 18n minus 40 equals 0. Alright, now this is factorable. We could actually solve it that way. Matter of fact, let's do that real fast. That's n, numbers multiply to be 40. But add up to be 18. So it's a negative and a positive, so negative 20 and positive 2. So the solutions to this are n equals 20 or n equals negative 2. Alright, so how to do this by completing the square. So first thing is, we have to determine what value completes this square. As we mentioned in the previous video, it'll be 1/2 of this term squared. Reason being, here's our square. That's n squared. This will be negative 9n. That'll be negative 9n, which makes this negative 9, this n, this negative 9, which makes this term 81. So it's 1/2 of this squared. So, here's one of the other things we do when completing the square. We normally actually isolate this extra term on this side first. So we'll get n squared minus 18n is equal to 40. And now to complete the square, we have to add 81 here. But whatever we do to one side, we must do to the other. So we're going to add 81 here and here. So we're going to put it here and here. So that's now n squared minus 18n plus 81. Something I forgot to mention in the previous video is that the term that completes the square is always positive. Because regardless of what these are, they're the same. They'll always be positive. So this will now become n minus 9 squared, which is equal to 121. Alright, and that's because this is n minus 9 times n minus 9. That's where that came from. That's what those three things became. Alright, now, to solve the equation, we take the square root of both sides to get rid of that square, and we get n minus 9 is either equal to the positive or negative square root of 121, which is equal to, write that down, which is equal to, so yeah, these are the two possibilities. We get n minus 9 is equal to, square root of 121 is 11, and the other version of this was negative 11. Alright, which give us n equals 20 or n equals 2, negative 2, which are the two answers we got before. So I want to make this more clear. Alright. If you multiply, it's positive and negative the square root of 121, which is 11. Because 11 squared will be 121, and negative 11 squared is also 121. So in case that's why that's not clear, that's what happened there. So yeah, in the first case we get n minus 9 equals 11, which makes n equal to 20. And in the second case, n plus, I'm sorry, not n plus, n minus 9 minus 9 equals negative 11, which means n is equal to 2, negative 2. So those are the two possibilities. Is completing the square harder? No. Why should we do it instead of factoring? The answer is we shouldn't. Factoring is much faster and easier. Although the benefit of completing the square is you can actually determine the solutions of unfactorable quadratic equations. So the reason they're unfactorable is because their numbers aren't integers. They actually, or even rational numbers, they have irrational results, so radicals. So let's take a look at an example where that will happen. Okay, so we're going to get rid of this one, and we're going to bring this one into play. Alright, so just like in the last case, it actually makes more sense not to have it equal to 0. We're going to move the 23 to the other side. Alright, and determine what value completes this square. So let's complete the square. That's k, the k squared. Each of these is going to be half of that 12, so that's negative 6k. That's negative 6k, making these negative 6. This will be 36, so we're going to add that to both sides. So whatever we do to one side, we have to do to the other. And this will become k minus 6 squared, always half of the middle term. And 36 minus 23 is 13. Now we take the square root of both sides, which is where things get weird, because that gives us k minus 6 is equal to positive and negative radical 13. Which doesn't have a square root, and in this particular case this radical can't be simplified, but in some cases it will be simplifiable. If it can be simplified, you should simplify it. So our final answer is k is equal to 6 plus or minus radical 13. So on a parabola you can think of that as this is the vertex. If this was the if you're looking at a parabola, the roots are the x-intercepts, so they're around here. This center point here, which is where the axis of symmetry is, this is 6, and plus radical 13 is over here, so this is 6 plus radical 13, and over here would be 6 minus radical 13. So from this center line, it'd be radical 13 to the left, and this one would be radical 13 to the right. So the answers are really k is equal to 6 plus radical 13, and k is equal to 6 minus radical 13. Alright, let's look at one more example. Alright, so we want to we'll want to set this up such that the negative 4 is the only thing on the other side. So move the 8x over here. Now, unlike in the other ones, the a term is actually not equal to 1, so the way to deal with that is to divide everything by a, which is 3 in this case. So that'll make this x squared negative 8 over 3x is equal to negative 4 thirds. Not pleasant to look at, but it doesn't change the fact that you can solve this quadratic equation without factoring if you complete the square. So let's look at what completes this weird square. That's x and x. This is going to be half of 8 thirds is 4 thirds, so this is going to be 4 thirds x. That's 4 thirds x. So that's 4 thirds. That's 4 thirds, making this 16 ninths. Alright, so we're going to add 16 ninths to both sides. These aren't the worst fractions in the world. Okay, so these become x minus 4 thirds squared which is now equal to negative 4. This is really the same thing as negative 12 ninths. So if we add 16 of them, that's 4 ninths. 4 ninths. Now we take the square root of both sides. Doesn't matter how complex the fractions are, they all work out the same way. Even works with decimals. We get x minus 4 thirds is equal to plus and minus the square root of 4 ninths, which is 2 thirds. So either x is equal to 4 thirds plus 2 thirds, which equals 6 thirds, or 2, or x is equal to 4 thirds minus 2 thirds, which is equal to 2 thirds. Alright. So those are the two possible answers. And just to confirm that, you can solve this by factoring. So looking back at the original problem, I'm going to do it over here. We can do this by factoring. So that's 3x squared minus 8x plus 4 equals 0. AC is equal to 12. So that's 3x squared, or two numbers that multiply to be 12 but add to be negative 8. So I guess negative 2 and negative 6. So that's negative 6x plus, oh sorry, not plus, minus 2x plus 4 equals 0. By factoring out the GCF of 3x, we're left with x minus 2. The GCF of these two terms is negative 2, giving x minus 2, so equals 0. So that gives us 3x minus 2 and x minus 2 equals 0, which means the solutions here are 2 thirds or x equals 2. Now, personally, in this case, I don't know which one I would prefer to use. I think I would probably complete the square, but it's really up to you in these kinds of cases. But for now, we're going to learn how to do this.